Hi, so this is part two of the videos on differentiation from first principles. So hopefully you've already watched the first video and seen that we've got this generalized rule for how to differentiate or how to find the gradient of a curve. And what I'm going to do in this video is just formalize that process of differentiation from first principles on two different functions and just put it into the context of exactly what you're going to be required to do when it comes to an examination question. So here we go. First one, or the first step, is going to be to state the formula for differentiation, so from first principles. So what that means is we're looking at that setup there. So we've got our curve, y equals f of x, and we've got the 2 points on the curve. This one is set up in terms of this function notation here. So if the x-coordinate is that, the y-coordinate is whatever we get from the function. Point B, if the x-coordinate is that, then the y value is what's coming out of the function from there. Now, you absolutely don't need to draw the diagram. I'm just putting that there just so you can see what's going on, so you'll understand where the bits and pieces are coming from. And the thing that you're going to need to state is for the gradient function, f dash x, we've got this thing here, which is limit, which is just basic notation we're saying kind of as h tends to 0. What we're going to get is the change in y on the top and the change in x on the bottom. There it is. So that's going to be the first point, kind of stating that rule there. So that pretty much that statement that we're seeing here, this line here, is pretty much going to be the same every single time. So you write that down first of all to tell the examiner, yep, okay, I know what I understand the process and know what I'm going to be doing. From here on in, we've got to now apply this, but in the context of our particular function. In this case, it's 6x cubed. So what we're going to do is our second step, put all that in. So now we're taking out the function notation and replacing it with the specific function. So what we've got is, there we go, there's our 6x cubed for this point up here, x plus h cubed, minus our other coordinate, and then I've just tied up the x minus the x, leaving h on the bottom. What we're going to do now is work with this, so we've got a bit of algebraic manipulation to come. So let's kind of expand out the brackets. So if you've done binomial expansion, that would be the way to go. If you haven't, then you are expected to be able to just multiply out 3 brackets. So you end up with this expression here in our brackets, times the whole thing by 6, and then have a look at what cancel you can do, and you will pretty much always be able to cancel out this first term here against a term at the back here. So let's get rid of those. There they go. And so we end up with that. Next step is to deal with the h. So again, what we're going to do is factorize the h's on the top and then cancel out against those on the bottom. So I'm just going to clear the screen and shift and create a bit of space for myself. Here we go. Factorize, take the h out of all those terms on the top, do the cancelling, and we end up with that. So that's what we're up to so far. And then the final step is we've got to say, well, what happens as h tends to 0, as h becomes infinitely small, and then what that's going to lead to as our final result. So here we go. We're going to say as h tends to 0, our expression for the gradient, this thing here, that's going to tend to, well, what's going to happen? Well, if we consider that one there, it's got an h in it. As h tends to 0, I've got 18x times by 0, so that's going to tend to 0 as well. And the same thing's going to happen there. As h tends to 0, h squared becomes 0. So essentially those two terms pretty much kind of disappear off. And so we end up with 18x squared. And then the final step is to state, yeah, there's our result. So the gradient function, f dash of x, is 18x squared. That's what we've got from doing our formal differentiation from first principles process, and that's the process that you're going to have to do in the exam. Now let's just check against our generalized rule, which was from the last video. Now you don't need to do this in the exam, but I'm just basically proving that we're getting the right result. So here we go. That was our statement for how we differentiate. Remember, if we said bring the power to the front, take one off the power. So let's have a look at that, how that works with regard to 6x cubed. So there's 6x cubed, so f dash of x equals, what we're going to do is bring the power to the front. So that 3 is going to come to the front and multiply the 6. The x is still going to be there. That's not changing. Take one off the power. That becomes squared. And you can see straight away, there's the 18x squared that we got from first principles. Moving on to the second example. So again, we've got our function 3x squared minus 5x. So off we go again, state the formula. There it is, same as we stated from last time, our general formula. Apply it to our specific function, so we're going to apply it to this function here. So we've got, there's 3x plus h squared minus 5x plus h, so that's the x plus h bit, and then we're going to subtract the original bit. And on the bottom, we've got the change in x plus h minus x. You'll find that that bit's going to be basically the same every single time. So, easy to simplify on the bottom, and we've got a bit of work to do with what's going on the top. So let's expand and simplify. This is the key thing here. This is absolutely vital. You'll notice I put our original function in brackets here because we're subtracting all of this. So you've got to make sure that you're using brackets here, because that's got implications for this sign. So be very, very careful with the use of brackets and what's going on with minuses. So there's the whole thing now multiplied out. Now, what can we do in terms of a bit of simplifying? Well, the 3x squareds are going to go. You'll notice the 5x's are going to disappear. And so we end up with 6xh plus 3h squared minus 5h all over h. So that's effectively steps 1 and 2. We've got to do a bit of factorising out and cancelling. So they take the h out of all the bits on the top and do the cancelling. There they go. So we end up with 6x plus 3h minus 5. Right, what happens is h tends to 0. So we're going to make the statement as h tends to 0. You're going to write that in your exam. So h tends to 0. So that means our expression 6x plus 3h minus 5 tends to, and again, it's this term here. That's the one that's going to tend to 0. So the whole thing becomes just 6x minus 5. And so, final step, just state the result. There it is, f-x equals 6x minus 5. Again, let's just check it against our generalized result. Let's bring the power to the front, knock one off the power. Let's see what happens. So, bring the power to the front, take one off the power, so that becomes 6x. Now let's just consider very carefully what happens with this one here. So thinking about this one here, what's going on is this is x to the power of 1. So the 1's going to come to the front. It's going to be 1 times 5, so the 5's still going to be there. That's going to be 1 times 5 is 5. And then x to the power 1, take 1 off the power, becomes x to the power 0. And as we all know, x to the power 0 is 1. So effectively it becomes, there's my mouse gone, 1 times 5 times 1. So it looks like the x is disappearing. It's not, it's becoming x to the power 0. And so that just leaves us with 6x minus 5, which is the result that we had from before.